So hi everyone, today I will be discussing example problems that involves the Doppler effect. So for the first example, we have a police car's siren emits a sinusoidal wave with frequency f sub s equal to 300 hertz. The speed of sound is 340 meter per second and the air is still. For A, find the wavelength of the waves if the siren is at rest. For B, find the wavelengths of the waves in front of and behind the siren if it is moving at 30 meters per second. Okay, so for this problem, we have here an illustration. So this is the police car, and then we have here its siren is emitting a sinusoidal wave. And then for the first, for letter A, it is at rest. Okay? So for A, our siren or our police car siren is at rest. So we will consider that it's V sub S is equal to 0. That's the velocity of the siren or the velocity of the source of sound. And then, okay, so take note that this arrow here is for the 30 meter per second. That is for the letter B in a question. So let us assume first that this is not included. Okay. So ayan. We have here Vs equal to 0. Our V is the speed of sound, that's 340 meter per second. And then we have the given f sub s, that is 300 hertz. Now we are going to look for the wavelength of the waves when the siren is at rest. Wavelength is given by lambda, okay, or is represented by the Greek letter lambda. Okay, now to solve this problem, recall that our velocity is equivalent to wavelength times our frequency. So for letter A, hindi muna natin gagamitin yung formula for the Doppler effect. Okay. Since the siren is at rest, so there is no motion or there is no movement involved, or the siren is not moving, or the police car is not moving, so we will use this equation or this formula to solve for the wavelength. Okay. Now, we will divide both sides by f, okay, in order for us to obtain the equation for lambda. So we have here Vf over lambda, okay, or I will rewrite this in a reverse way. That's lambda equal to our velocity or our speed divided by our frequency. Okay, so our speed is 340 meter per second divided by our frequency, that's 300 hertz. So this will give us 1.13 meters. Now, why our unit is meters? So we are talking about wavelength, so its SI unit is actually meters. But if you look at this units here, okay, so ms divided by hertz is actually 1 over s. No? So magiging ms times the reciprocal of the denominator, so this will cancel out. We will be left with m. Okay, so that is the reason why we have here the unit m. Okay, except that we all know that the SI unit for wavelength is meter. So if magbabase tayo dito or magbe-base tayo sa units na ating given, it will arrive at meter or in meters. So this is now our answer for letter A. Okay. Now for letter B, we have here, okay, I will write again our given. We have our frequency, 300 hertz, our V or our speed of sound, is 340 meter per second. Now for letter B, we are going to look for the wavelengths, okay? But the siren is now moving. Okay? So our source of sound is now moving. Okay? So we have 30 meter per second. Now, the formula that we are going to use in solving this is the wavelength in front. Okay, so please take note of this formula. It's V minus Vs over Fs. So this is the wave of sound minus the wave of the source of sound, or the wave of our siren, divided by the frequency of our siren, okay, or our source of sound. Okay, so this is, okay, so later ko na lang siya i-substitute for the wave behind, or the wave behind. We have here the wavelength behind. We have here V plus Vs over Fs. So these are the formula to be used, okay, if we are going to look for the wavelength. Wavelength is or lambda. Okay, that's it. Now, so we are going to substitute, okay, our given. So this is for the wavelength in front. Okay, I will do this first. We have our V, that's 340 meter per second minus 30 meter per second divided by 300. So to calculate this, you will obtain 1.03 meters. Now for the wavelength behind, we have 340 meter per second plus 30 meter per second divided by 300 hertz, which will give us 1.23 meters. Okay, so this is now our answers for letter B. Now, you can observe here that the wavelength, okay, wavelength is shorter in front of, okay, in front of the siren. Wavelength is shorter in front of the siren and is longer behind the siren. So here you can see naman that 1.03 is shorter compared sa 1.23. So this is the conclusion that we obtained from our results for letter B. Okay, so for our second example, we have a police car siren emits a sinusoidal wave with frequency f sub s equal to 300 hertz. The speed of sound is 340 meters per second, and the air is still. If a listener L is at rest and the siren is moving away from the listener at 30 meters per second, what frequency does the listener hear? So notice that our first two sentences is the same with the previous problem. So what we did here is, or what we're going to do here is, let's say we have a listener. A listener is at rest, and then our source of sound, or our police car siren, is moving away from the listener at 30 meters per second. Now we are going to look for the frequency of what the listener can hear. Okay, so you can see here an image or a diagram that illustrates the problem. So this is our listener, okay, ayan. And then which is at rest. Okay, so we have the speed of the listener is at 0 since it is at rest, and then this is the police car siren, which is moving away from the listener. So we have this arrow pointing this way. So if we have this listener to source of sound, it is positive. First, to answer this problem, we will write our given. Okay, we have our Fs, that's 300 hertz. our speed of sound, it's 340 meter per second. The speed of our sound source or the siren, that is 30 meter per second. The speed of our listener, which is at rest, so 0. And then, yes. Now, what does the positive mean? Okay, so we indicate this positive. Ito siya. It is because the velocity or the speed, direction of the speed is coming from the listener to source. Take note that if we have listener to source, it's always, your velocity is always positive. Kapag baliktad naman, pag source to listener, okay, we have it as negative. So later, we have an example for that. Now, to solve this problem, we are going to use our formula for the Doppler effect. That is F sub L equal to V plus VL over V plus Vs times Fs. So this is your frequency for the listener equal to the wave of sound plus the the speed of sound, that is V, plus the speed of the listener divided by the speed of sound plus the speed of the sound source times the frequency of the source or the siren for this problem. Now, since VL is 0, our formula becomes V over V plus Vs Fs. So ito siya, equivalent ito sa 0, so mawawala siya dito sa formula. Kasi V plus 0 equals V. Now, plugging in or substituting our given values, we have 340 meter per second divided by 340 meter per second plus the speed of our sound source, that's positive 30 meter per second. This will give you, or this will give us, times frequency, that is 300. Sorry, I forgot the frequency. So you have to divide this first before multiplying with 300 hertz. So i-divide muna natin ito before the 300 hertz. Before multiplying it with 300 hertz, now you will arrive with 276 hertz. So take note that hertz is our SI unit for frequency. And then, paano siya naging hertz? Maka-cancel out kasi yung meter per second dito, itong unit na ito. So matitira lang si hertz. That is why our unit will become hertz na lang. Okay. So this is now the answer for this problem. Okay, now for this example, it's the same. The first two sentences is the same with the previous examples, but for this case, the listener is moving and then the police car is at rest, okay, or the source of our sound now is at rest. So unlike the previous example, we have the listener is at rest and then the police car is moving. For this case, it's the opposite. Okay, so this problem states that a police car siren emits a sinusoidal wave with the frequency f sub s equal to 300 hertz. The speed of sound is 340 meter per second and the air is still. If the siren is at rest and the listener is moving away from it, at 30 meter per second, what frequency does the listener hear? Okay, so to solve this problem, we will first write our given. So we have our V, or our speed of sound, that's 340 meter per second. Our frequency for the police car sirens, that's 300 hertz. The velocity of the police car siren is 0 since it is at rest. For the listener, we have it at 30 meter per second. But since the listener is moving away from the source, we have it as negative. So unlike kanina, the listener is, I'm sorry, the source is moving away from the listener. So we have positive velocity. Okay. But for this case naman, the listener is moving away from the source. So we have a negative velocity. So we'll just write here, it is negative if from source to listener. Now, we are going to look for the frequency of the listener. So we will use the same formula for the Doppler effect. We have FL equal to V plus VL over V plus VS times FS. Since VS is 0, our formula becomes V plus VL over V times Fs. So we will plug in now the values. We have 340 meter per second plus negative 30 meter per second divided by 340 meter per second times the quantity 300 hertz. So this will give us 277 hertz. So this is now the frequency of the listener when it is moving away from the source of sound or from the police car siren. Now for the last example, we have a police car siren emits a sinusoidal wave with frequency f sub s equal to 300 hertz. The speed of sound is 340 meter per second and the air is still. The siren is moving away from the listener with a speed of 45 meter per second relative to the air, and the listener is moving toward the siren with a speed of 15 meter per second relative to the air. Now, what frequency does the listener hear? Now, observe that both the listener and the siren is moving. Okay. And then you can see here from the diagram, okay, that we have here arrows, okay, that indicates the direction of both the listener and the police car. Okay, so to solve this problem, we will write first our given. We have our frequency for the source of sound or the police car siren, that is 300 hertz. The speed of sound, that's 340 meter per second. The speed of the siren moving away from the listener, that is 45 meter per second. And the speed of the listener, that is 15 meter per second. Now we are going to look for the frequency of the listener. Now note that both the velocity of the source or the siren and the listener are positive since their directions are from listener to source. So you can see here the arrow from the diagram. So both are positive. So here we are going to use the formula for the Doppler effect, that is F sub L equal to V plus VL over V plus VS times F sub S, sorry. So we will directly plug in now or substitute now the given values. So in this case, wala tayong at rest from the listener and the source of sound, so both are in motion. So we will directly substitute our values with their respective variables in the formula. So we have 340 meter per second plus positive 15 meter per second divided by 340 meter per second plus 45 meter per second times 300 hertz. So you will be arriving with 277 hertz as our frequency for the listener. So this is now our final answer. Okay, so that's all for the examples of word problems that involves the Doppler effect. If you have questions, clarifications, and suggestions, please feel free to approach me through my Facebook Messenger. That would be all. I hope you have learned something. Enjoy learning. Goodbye.